So good morning all of you. Today we are entering into the fourth unit of our operating system, Introduction to Operating System. So today we'll be studying what is called as storage management, or what is storage management and how does operating system perform the function of storage management. Okay. So for all these things we can take an analogy of your bedroom. You have different kinds of dresses. Likewise, you have different kinds of files. You need to keep it arranged, stored, so that whichever dress you want to take, you need to take it as per your convenience. If you don't have any bureau or anything, what you do, we buy an extra bureau or something, we keep an extra storage device, right? The same way, here also we'll be studying about what is mass storage system, what is a disk, what is a magnetic disk, and how to schedule and manage risks. The job of the operating system involves managing the disks, external storage systems. Okay, so how that happens. Second, the next thing what I thought that I could cover in this session is about file system interface. How do you create files in your, how is files created in your system? And what is the role of operating system in creating files? What are the different types of files? When you want to install a software, the first thing they ask you is, what operating system are you using? Whether you have a 32-bit or a 64-bit operating system, whether you are using Windows, Unix, Linux, or any other flavor of Linux or anything like that, Fedora, Ubuntu, and so on. So you have so many operating systems, and here we are studying the principles behind the operating systems. So we won't be going specifically about one particular kind of operating system, but we'll be studying in general about how an operating system works. So in the first unit we have studied the overview of operating systems, what are its functions, what are its objectives, what are the things that it manages. Second unit we have studied what is meant by a process, how process is being managed by an operating system, process management in operating system. The third unit we studied about memory management. Fourth unit we are studying storage management. Memory management means we are concerned with the main memory and its aspects. Okay, so in this fourth unit we will be studying how operating systems are used to manage devices, external storage devices, such as magnetic disks and so on. Of course, magnetic disks are outdated today. Today you have pen drives and you have cloud storage, you have so many other ways of having memory and using it. Previous year syllabus is slightly having some portions that is a part of our history. How we came down last class or in previous sessions I told you about floppy disks. We had floppy disks, from then we came into CDs and DVDs, right? Okay, what is a CD? Is a magnetic device used to store information, right? We had CD writers. How many of you have seen CD writers? I've used a CD writer. You cannot simply copy things into CDs. You need to have a CD writer and all those things. But nowadays we don't have all these things. All these things are eliminated because we have much easier ways of mass storage mechanisms. Today we are using pen drives, we are using Google Drives, we are using other mass storage systems like OneDrive, or so many other things are available for us, right? When you take photographs in your mobile phones, these photographs are stored into cloud, accessible by anybody. Am I right? If at all you give permissions, it is accessible by you anywhere in the world. So these are all mass storage systems, systems that have an external storage not connected with your internal memory. Is that okay? You have some file that you are downloading in your mobile phone. You're saving that. That's not saved in your mobile phone. It is saved somewhere in the internet so that you can access it anywhere else. So this is one example of mass storage system. But we are not studying the latest things. We'll be studying about how compact this works, what is disk management, what is disk scheduling, and so on in the fourth unit of our subject, Introduction to Operating Systems. So what is storage management and why do we need external storage? Basically, main memory is too small for us. We cannot store all the information in the main memory, right? We need to have additional space. So what we do is that we depend upon external storage devices. So we have this kind. So storage management refers to how this data is stored in the external devices like magnetic disks or cloud or whatever it is. All these things are managed by your operating system. Okay. So storage management is how this data is stored, organized and accessed in your computer where the information is actually stored somewhere else in external devices. So you have three types of storages in general. One is called as the primary storage within your own system. Everything that you save, your phone has its own memory. You save 128 GB, 512 GB, 256 GB and all right. So much of gigabytes is being stored inside your system. Then it's about hard disk, external hard disks and so on. Today we have hard disks of the range terabytes. And tertiary or the additional offline storage devices like pen drive. And you have this, what do you call that, magnetic cards, no? External hard disk cards, which you insert inside your mobile, SD cards. These are all external storage devices. And all these things, once you insert a card or a pen drive or anything, all these things are controlled with the help of the operating system. The operating system is the one that learns about its space available, what are the things to be done, how to format it, and so on. So we'll see what are mass storage systems, and we'll be primarily concentrating on our magnetic disks. Previous generations, or a few years back, maybe around 10 years back, so we didn't have any kind of mass storage systems or the idea of storing data in terms of terabytes of information. Terabytes was almost the things that we could not even think of. So at that particular time, even 100 or 200 MB of storage was a big challenge. So that is what we call, that's what was solved using the external systems like compact disks, where this data is stored in the magnetic tapes. Okay, data is stored in the magnetic tapes. And that times when mass storage systems like compact disks were used, 300 or 400 MB itself was a big challenge. Today it is not like that. Today we have terabytes of information. You have Google is offering you 15 GB free space. Okay, if you create a Google Drive, you have 15 GB free space. Now, if you log into your official account, ECET online, you have unlimited storage of, you have options to store infinite amount of information in your account. Okay, so these are all places where you save your information. Yes, to save data, we need external mass storages, things that can be retrieved. Okay, there are certain things that you cannot store in external devices also. As we go on, we learn all those things. So given here is a picture of an old magnetic tape. How many of you have seen this kind of discs. You might have seen that movies. Even today, I think even your stereo players and car players, you have this. But it is replaced by your USB drive, right? All music, all videos, all these things can today be saved in USB drives. Previously, it was not like that. Okay. USB is the port which is connecting you to the secondary storage device. So we had disks previously. These disks were stored, disks were used to store information. So these are some examples or some mass storage devices. See, we cannot include all. I've given you a few examples according to your syllabus and your requirements. One, we have the hard disk drive that is there already inside your system or in all your systems. We have, even in your mobile phones, you have external storage systems. Not external, it's internal actually. But not RAM, not the main memory. We have solid state devices, we have magnetic tapes, we have optical disks, flash drives like USB storage, and the most important, the most widely used today is the cloud storage. That means you store all your information in cloud. I told you just now, you have Google Cloud where you store all your information. Similarly, you have Dropbox. How many of you have used Dropbox here? These things can be used to store your information, your notes, your materials, your research work, and everything. Okay, so this cloud storage is the most prominently used today. We have all other kinds of mass storage devices. I've given you an example of few. So the image on the, or the diagram on the right side shows the way magnetic disk store the information. We have different cylinders. We call these as cylinders. We have a plater, cylinder, sector, and track one spindle. See, I don't want you to be well aware of things that how a disk storage is being done, because it is beyond the scope of our study. You don't need to use that at all. And today it is also almost, what do you say, extinct. Extinct means not used today. Very rarely used. So what are the, purely a theoretical question that generally comes in your exams? What is the advantage of using a mass storage system, or why do we need to have a mass storage system? So a purely academic question about what are the advantages of using mass storage systems. It has an efficient utilization of storage space. We have discussed all these things, a fast and optimized file access. I've told you that all files are not suitable to be saved inside the secondary storage systems. Data security and protection, crash recovery. It reduces the possibility of crash. And there is one more advantage. Now, if you do not have any UPS, if you have a secondary storage device, if you have done something and if the power fails, still it is saved in the secondary storage device. Some things like that is there. Or if there is a crash or some other exigency. Exigency means some other emergency where your main system or main memory cannot function properly. We use secondary storage devices. Disk management. So far we have seen what is a compact disk or what are magnetic disks, what are secondary storage devices, and so on. Now we'll be having an overall view of what operating system is expected to do. I'm sorry for the interruption now. Now we'll see, we have seen what is a compact disk or what is a magnetic tape or what is a mass storage system and what are its advantages, how it works. So How it works is not very important. But these are the things that we have seen. Now what we'll be doing is that we will be studying how the operating system is going to manage the disk, or how OS is going to affect the or do these certain functions for the magnetic tapes, that is an external or a secondary storage device. So we have already seen. Now can you understand the difference between unit 3 and unit 4? In unit 3 we studied memory management system, primary memory. In unit 4 we'll be studying storage systems, that is secondary and tertiary storage systems. How operating system is going to manage the secondary and tertiary operating systems. That is what we are seeing in the fourth module. In the third unit, what we studied about the main memory, page, segmentation, and so on. That's all the direct RAM. That is the direct access. We have external storage devices and how operating system is used to manage this kind of secondary and tertiary memory is what we are studying right now. Is that clear now? So what is the job that OS does? Okay, first thing is that it finds out how much free space is available. When you insert a disk or a pen drive in your system, it will see how many space, what is the space available, whether we can store so many files or not, and so on, right? Free and use space, it can format also. It can help in organizing the data or the files more efficiently. And it can protect the data also. You can use protect mode. All these things are being done by the operating system. You can keep the data locked. Okay. These functions are done by the operating systems. Disk scheduling algorithms. Next, very important topic and a very common question in your exams. So you need to have scheduling algorithms because you have to prioritize what is that you want. What should be done first should be done first, right? That is called as scheduling. We have different types of algorithms to schedule the disk access from the operating system, and this disk scheduling algorithms are implemented by the operating system. So what are the different types of disk scheduling algorithms is what we'll study. So the objective of this scheduling algorithms is to improve throughput and response time. Okay, so it has to do things much quicker, or the way in which your disk or your external storage responds to the request from the operating system should be much faster, so that you can schedule these things accordingly. Otherwise, you might find that your system gets stuck, right? So the first algorithm, number one, here you can put the first algorithm. First come, first serve. Very easy. The requests are processed according to the order they arrive. The first one, whichever comes, is given the first chance. So here, there is no reordering, so it is very easy to implement it. There is no work to be done. Operating system can easily do whichever comes first, can be given the first things. So advantages is that it is fair because there is nothing to be done. Simple to implement. High seek time. Okay. Some things might take more time, or some things which is having low priority may take more time. So the high priority process has to keep waiting. And the performance is poor if the requests are scattered. And the poor performance if the request is scattered. Okay. What happens if two requests come at the same time? So there are so many disadvantages like that. The second type of algorithm, number 2, is called the shortest seek time first, SSTF. Which one of the request is having the least seek time is given the first preference. Disk scheduling algorithms, the first one, first come, first serve. Second one is that the shortest seek time is given the first preference. Okay. So the average seek time now, see whichever is given, the smallest one is given the first one. So it will happen very fast, right? So we have the advantage that the average seek time will be much less, so that the overall performance of the system will improve. So what happens is that the average seek time is reduced and better throughput. We have seen that our objective is to reduce the response time and maximize the throughput, right? These are the objectives of scheduling algorithms. What are the two objectives of the scheduling algorithms? Can anyone tell me? No, that is algorithms. What is the objective? Why do we want these algorithms? Or what this algorithm does? First thing is that the objective is to improvise the throughput, increase the throughput, and reduce the response time. Quickly, access should be there. So the objectives of disk scheduling algorithms are, first one, to reduce the response time, and the second one is to improve the throughput, right? So here, when compared to our first type of algorithm, FCFS, this has both the advantages. Starvation possible, faraway requests may wait indefinitely. Not optimal for all workloads. There might be situations where you need a high priority process or high priority storage, but may take some more response time or seek time. So in that case, you cannot identify which to be done when. Okay, only the seek time is taken as a criteria in this algorithm. Scan or elevator algorithm. Make a note of this. After you make a note of this, I'll explain, because when I'm explaining to you, you are not now, you're not listening to me and you're writing something. So far we have seen only algorithms that's based on the request. Now we are seeing another one that is based on the movement of the disk. Which disk, on what type it moves, so that things, the seek time will be much effective, right? So that's called a scan or elevator algorithm. This is the third type of algorithm that is used for disk scheduling. Today we have studied. The advantages is that there is no starvation at all. You know that it happens very quickly. The seek time is much less when compared to both the other algorithms, FCFS, first come first serve and shortest to seek time first. Both these algorithms, this is much more efficient for heavier loads. Long wait time is a disadvantage that we have. See, most probably whenever you are asked to write about these scheduling algorithms, you need to write the algorithm and how it works. I've just given you these points. What you have to do is that you have to expand this and write enough, and then you have to write the advantages and disadvantages of each kind of algorithms. So the third type of algorithm is scan or elevator algorithm. C-scan or circular scan, the another type of disk algorithms. So instead of reversing, like to say, what happens in the previous here, instead of reversing, what it does, it returns to the start and then scans it. This is circular scan, the other one is scan elevator. That means depending upon whichever is available, that is done first. More uniform, this is slightly advanced. See, you can see that from the first come first serve, each type of algorithm what they study is slightly advanced than the previous kind of algorithms. So first two was good, provided you have all these things ready. The third one, what we are doing is we are simply scanning the disk, and whichever is available, that is what we are using. Okay. The next type is not simple scanning, an advanced method, one more circular scan. Treats the disk as a circular disk. This is why advantages are very important, because each stage you come across, you have more advantages, right? So more uniform wait time. There is it's slightly better in that condition that it is wait time is reduced. Okay. Waste time during the return to start because it has to come back naturally. The next and the last type of scheduling algorithm that we are going to study today is called as look and see. Look, that is an optimized scan algorithms. When you compare this with the previous ones, it has much less seek time. So as I told you, the main objectives for these disk scheduling algorithms are to increase the throughput and reduce the seek time. So it's more complex, but still it has effectiveness in reducing the seek time. Okay. So what are the 6 kinds of algorithms we have seen today? This reverses the direction when no more requests are there in the current direction. So it is a combination of elevator scan and the circular scan. Okay. This is a combination of elevator scan and the so finally we'll give a comparative chart about all these 5 types of algorithms, its advantages and disadvantages. This is a summary of what we have seen today. The summary of the entire class, what we have seen today about these 5 kinds of algorithms. This is called as first come first serve, shortest seek time first, a regular ordinary scanning, circular scanning, look or see look scanning. So from here onwards, the scan, see scan, and look or see look scan, we are working with the way the disk functions. It's a basic comparative chart for you to write better in your exams. So it's, you can make rough notes on this. So thank you very much for attending the session. Have any questions?